Good morning. Today we're doing lesson 11.3, which is solving radical equations. So the other day we did expressions. Now we have equations with an equal sign. So our key concept today is squaring both sides of an equation. If two expressions are equal, then their squares are also equal. So for example, if a is equal to b, then a squared must be equal to b squared. So they're telling you that the square root of x is 3. Well, if I square one side, then the other side, also squared, must be true. So we need to solve this. We're going to use this skill in a little bit. So we're going to solve just like a regular equation. We want to try and get the square root all by itself so we can get rid of it. So just like we've always been doing, we're doing the order of operations, but we're doing it backwards, always getting rid of addition and subtraction first, and then multiplication and division. So first let's get rid of addition and subtraction. The opposite of subtracting 8 is adding 8. So we have 2 square root of x equal to 0 plus 8 is 8. And then this is really multiplied because they're touching. So the opposite of multiplying by 2 is divide by 2. 2 divided by 2 is just 1. So we have 1 square root of x, or just square root of x. And 8 divided by 2 is 4. So now we have the square root by itself, but I want to know what is x, not the square root of x. So we can use this skill that we learned up here, which is to square both sides to get rid of the square root. So if I square this and square this, a square root and a square are opposites, they cancel out and just leave me with x. And 4 squared is not 4 times 2, it's 4 2 times. 4 times 4, which is 16. So my answer, x is 16. So it says check it. I'm going to rewrite this, but I'm going to plug in, instead of an x, I'm going to plug in 16. Let's see if it's true. The square root of 16 is really just 4. So if I follow the order of operations now the correct way forwards, 2 times 4 is 8, and 8 minus 8 is 0. 8 minus 8 does equal 0, so we know it works. We got the correct answer. So let's try the next couple here. We want to get this square root all by itself, so I need to get rid of this plus 5, so I'm going to subtract 5. So those eliminate, and I have the square root of 5x equal to 0 minus 5 is negative 5. Now this is where you need to be careful. We have a square root of a number, 5x, equal to a negative number. So if you ever have that, if you come across an equation that looks like that, you're going to want to stop and think about it. Because can you have the number multiplied by itself to equal a positive under the square root? Well, right now it makes sense, like, because a negative times a negative could equal a positive, but this is really going to be no solution, because a square root of a number is never going to be negative. Like the square root of 16, for example, is 4. It's not negative 4, it's always a positive number. So even if you weren't quite sure and you wanted to keep going because you're not sure if it's an answer or not, the opposite of a square root would be to square this side and to square this side. Those would cancel and leave us with 5x equal to negative 5 squared, which is positive 25, because a negative times a negative is positive. If I divide by 5, I get x equals 5. But if I go to check that, I have the square root of 5 times x, which is also 5, plus 5 equals 0. Well, 5 times 5 underneath here is 25. And square root of 25 is just 5. Does 5 plus 5 equal 0? Well, no, that doesn't work. So now we know that if we were to continue, this wouldn't work. It wouldn't be a nice answer, so you'd have to stop and not even go any further and just say no solution at this point. Alright, let's try the next one. We're going to get our square root all by itself. Get rid of our addition and subtraction first. I'm going to subtract 12. So those eliminate. I have 4 square root of x minus 7 equal to, subtract 12 on this side. That gives us 16. And then this is multiplied, so we need to get rid of that multiplication. I'm going to divide by 4. So I have the square root of x minus 7 equal to 4. And now we need to get rid of this square root. The opposite of a square root is to square both sides. Just like if I was to multiply by 5, I would have to do it on both sides. Just like I subtracted 12, I did on both sides. So our square root and our square cancel and leave us with x minus 7 equal to 4 squared. 4 times 4 is 16. And then last, just add 7. So we have x equal to 16 plus 7. Well, 6 plus 7 is 13, so 23. If you're not sure, check it. Some of you can check it right by just plugging it in here. 23 minus 7 is 16. Square root of 16 is 4. 4 times 4 is 16. 16 plus 12 would give you 28. If you can just plug it back in by looking at it and using mental math, great. If you need to write it out, that works too. Next we have an equation with radicals on both sides. So just like we did before, to get rid of our square root, we can undo it by squaring both sides. As long as that's the only thing on that side. So a square root and a square cancel, leave me with 3x minus 17. And on this side they cancel as well and leave me with x plus 21. So now we just need to solve this. I'm going to move my 1x over to the other side, subtract 1x. So those eliminate. 3x minus 1x is 2x. And over here I have 21. And then continuing on, get rid of addition and subtraction. I'm going to add 17. We have 2x equal to, well, 7 plus 1 is 8. And there's 3, 38. And then last, divide by 2. We get x equal to, well, half of 30 is 15, and half of 8 is 4, so 15 plus 4 is 19. So if you want, again, plug it back in to double check you got the right answer. It says the square root of 3 times 19 minus 17 on one side. And over here I have the square root of 19 plus 21. Again, just double checking it, make sure we got the right answer. I know this side will be a little bit easier, the square root of 40. And on this side, I'm going to plug 13 times 19 into my calculator. I get 57. But then I have to subtract 17. 57 minus 17 is also 40, so square root of 40 equal to square root of 40. I don't even need to solve that because it's the same thing on both sides. I know that's correct. So our answer is good. Alright, next we have the square root minus another square root equal to 0. Well, on this last one I had square roots on both sides and I was able to square it to make them go away. So what if I just moved or added this square root of x over to the other side? Now I have, just like the last one, the square root of 4x minus 3 equal to the square root of just x over here. Now I can get rid of my square roots by squaring both sides. So those eliminate or cancel out and leave us with 4x minus 3 equal to x. Now our goal is to get x by itself so we can solve it, so we need to move them all together. So I'm going to move this 1x over to the other side. If you wanted to move the 4 over to the other side, that's fine too. So 4 minus 1 is 3x minus 3 equals 0. So get rid of addition and subtraction first. I'm going to add 3. So I have 3x equal to 3. And then divide by 3. 3 divided by 3 is 1. Alright, these next two we need to do the same thing with. This one here, we have square root minus a square root. Well, let's just move it to the other side so that they're equal to each other. So I'm going to add the square root of x minus 15 add the square root of x minus 15. So I'm going to have the square root of x minus 18 equal to the square root of x minus 15. Sorry, my handwriting's a little sloppy there. Now I can square both sides, and I'll be left with x minus 18 equal to x minus 15. So here, when I go to solve this, I want all the x's on the same side. If I subtract this 1x, these eliminate and those eliminate. 1 minus 1 is nothing. There's no x's left, so you don't even write an x. We have negative 18 equal to negative 15. Well, we can't have that, so this one would be no solution. Because we're dealing with square roots, our answer is really no real solution, meaning when we get to calculus and other later classes, when we do square roots, we will have imaginary numbers, but for the sake of this problem, there is no real solution. There's no positive real answer. Alright, next one. We want the square root all by itself, so I'm going to move this negative 12 over to the other side. I'm going to add 12. Those eliminate, and I have the square root of 5x plus 4. And negative 6 plus 12, there's more positives. 12 minus 6 is 6. And now I need to get rid of this square root. So just like we've been doing, we're going to square both sides. So those cancel, and we have 5x plus 4 equal to 6 squared. 6 times 6 is 36. And then get x by itself. So subtracting 4, we have 5x equal to 32. And then divide by 5. So we get x equal to 32 divided by 5. Well, we know that's not going to be a nice answer. It's going to be 6.4. This is one that if you get an answer like this, you might want to double check it. 5 times 6.4 is going to give you 32. 32 plus 4 is 36. Square root of 36 is just 6. So 6 minus 12 does give you negative 6. So this is, in fact, correct. Alright, now it says solve an equation with an extraneous solution. Extraneous, what does that mean? Extraneous has the word extra right in it, so we might have one extra answer. So we need to solve this. Let's see what we're going to end up with. We already have the square root by itself, so I can square both sides right away to get rid of the square root. So I have those cancel. I have 6 minus x equal to now x squared. Alright, well we haven't had any so far that have an x squared and an x, so we need to think about what we've done in the past. Back in chapter 9, we actually did some problems where we had 3 terms and they were all equal to 0. So we're going to make this equal to 0. We don't want our first term negative though, so I'm going to move these ones over to the other side. So I'm going to add 1x, x squared plus 1x, and then I'm also going to subtract 6. You could have done those at the same time. X squared plus 1x minus 6. So now you guys, we have 3 terms. Those of you who are in 6th hour, this is not going to make any sense to you, so skip this problem. But for the rest of you, this is our diamond in our box. We're going to multiply our first term and our last term, negative 6x squared. Our middle term goes in the bottom. And we're thinking what multiplies to get negative 6 but adds to get 1? Well, the only multiples of 6 are 3 and 2. Those multiply to get 6. So to have more positives overall, 3 minus 2 would give you 1 and multiply to get 6. So from here we would do our box. And we have 3x and 2x. Those were our two sides that we just figured out. Oh, negative 2x. And our first term comes from the first term in this equation over here, x squared. Our last term is from the last box, negative 6. So think, what multiplies to get x squared? Well, x times x. Then x times negative 2 is negative 2x. X times 3 is 3x. So my answers here, I have really the two sets of parentheses are x minus 2 and x plus 3. So because this is equal to 0, we actually need to solve both. We have x minus 2 equal to 0 and x plus 3 equal to 0. When we solve these, hopefully you know what we're going to get because it's just the opposite. X equals 2. And solving this one, x equals a negative 3. Now let's think for a second. They asked us if we had any extraneous solutions. We learned earlier that you can't have a square root equal to a negative number. So if x was a negative 3 here, we would have our square root equal to a negative number. So this is actually an extraneous answer, which means it's not going to work. It's extra. So this would be our one answer that we can use. Alright, the next two just say determine whether the given value is a solution of the equation. So here's the end of our equation. We need to plug in 2 for x. So we have the square root of 2 times 2 plus 5. We need to see if that equals 3. Well, order of operations says multiply first. 2 times 2 is 4. So we have 4 plus 5. 4 plus 5 is 9 underneath the square root. Square root of 9 is just 3. So your answer would be yes, 3 does equal 3. Alright, same thing on the next one. We're going to plug in a negative 5 for x. So we have 3 times negative 5 and then minus 1. See if that equals 4. 3 times negative 5 is negative 15 minus 1. These are all negatives, so this is the square root of 16, negative 16, sorry, they're all negatives, equal to 4. Now this looks like a nice answer, but if you were to go further, well, two things. One, you can never have the square root of a negative number, you get an imaginary number. But if we were to undo this square root by squaring, those would cancel and we would have negative 16 equals positive 16. Well, that's not true. So this one is no real solution. You can stop back here when you have the square root of a negative number, or if you continue to solve it, it's not going to work out. Alright, this next one here, we have two square roots. We need them on opposite sides here, so I'm going to add this one over to the other side. 1 minus x. Add the square root of 1 minus x. And we have the square root of 21 minus x equal to the square root of 1 minus x. So just like we've done before, get rid of our square root by squaring, so they cancel. And leave me with 21 minus x equal to 1 minus x. So maybe some of you can see what's going to happen here. If I try and add this 1x to the other side, negative 1 and positive 1 eliminate, and I get 21 equal to 1, because those also eliminate. 21 is never going to equal 1, so this is no solution. There is no real solution. There might be an imaginary one, we just don't know what those are. Sorry, you can hear my sink and my dishwasher in the background. Alright, last one here. We have a square root. We need to get rid of that square root, so I'm going to square both sides. So those cancel, and we have negative 4x plus 5 equal to, this is squared, so be careful, 3x squared is 3x times 3x So we have 3 times 3 is 9, and x times x is x squared. This one is also one that if you are in 6th hour is not going to make any sense for you, so you can skip this question. Because we have 3 terms, we need them all on the same side. I'm going to move this 4x over to this side, add 4x. While I'm at it, I'm going to subtract 5. Just do it all in one step so we get rid of that and make it equal to 0. So we have 3 terms. We're going to do our diamond and our box from here. This is called factoring our polynomial. So we're going to multiply our first term by our last term. 9 times negative 5 is negative 45, and we have an x squared. 4x goes in the denominator, the bottom. That's not the denominator, just a diamond. We need to think what multiplies to get 45, but adds to get 4. What about the 2 we just multiplied? 9x and 5. Those will multiply to get 45, and 9 minus 5 will give you 4. So in our box, we have, draw it out here first. Again, feel free to pause the video if you need to. My 2 side ones go in our diagonal. We have 9x and negative 5x. First term from our equation was 9x squared. Last term was negative 5. So my answers here, I have x times x is x squared. But I need a 9. It could be 3 times 3, or it could just be 9. Well, if I use 3 and 3, that's not going to give me 5. But these both have a 9, so I can just put the 9 up here. That'll give me 9x squared. X times negative 5 will give me negative 5x. 9x times just 1 would give me 9x still. And then 1 times negative 5, yep, is negative 5. So my 2 sets of answers, or parentheses, are going to be 9x minus 5 and x plus 1. Because it's equal to 0, we need to solve both. 9x minus 5 equal to 0, and x plus 1 equals 0. So if I add 5 here, I get 9x equal to 5, and divide by 9, we get x equals 5/9. It's okay, I'm just going to leave it as a decimal for now, or a fraction for now. And then here subtract 1. We have x equal to negative 1. Those are our 2 answers. However, it says check for extra or extraneous answers that might not work. So we have 5/9, we have negative 1. Always double check your negatives. If this was my original equation, and I have a negative 1, 3 times a negative 1 would be a negative 3. You can't have a square root equal to a negative number, so I know this is an extraneous or an extra answer that we don't need. So the only answer that might work is 5/9. Alright, there are a couple questions that you can cross off because I don't need you to describe the steps you would use to solve. It says don't solve. I just want you to solve the other ones, okay? Ignore, what is this, 7 through 12. And then the last 2 you can skip as well. I just simply want you to know how to solve a square root problem. If you are in our 6, you can also cross off on this last page here. All those are good. These last 3. Only for our 6. I'm really impressed. That was a really straight line, you guys. Alright, but everyone else, you need to do the rest of these. Alright, good luck.